My dear friends, welcome to Rajashekhar classes on applied data science with Python. This is lecture number 396. In this lecture, we will try to understand building a decision tree information gain. Since we have learned the idea of what entropy is, the next important concept is called the information gain, often written as IG. How can I write information gain? I subscript G, isn't it? So let's understand information gain. So let's see what information gain actually means. This is my root of the decision tree. This is my root of the decision tree. At my root, my total data set here. Just see, you can see the total data set. What we care about, class label y, isn't it? What is class label here? How many class labels are there? Y plus, y minus. At the root node, at the what is the root node here? We are saying outlook. At the root node, what is the entropy at the root node? H of entropy at root node is, let me say, 0.94. This I already discussed in just let me go to that particular lecture. This is lecture number 391 where we discussed about entropy. Just see, y play tennis, there are two options, y plus, y minus. Probability of y plus is 9 by 14, probability of y minus is 5 by 14, h of y equal to sigma I equal to 1 to k p of y into log p of y base 2. This is the value. Entropy h is 0.994. We said that h of y equal to, what is h of y? H of y equal to 0.94 at the root node, because if you remember what we did, minus 9 by 14 log 9 by 14 base 2 minus 5 by 14 log 5 by 14, because there are 9 positive values and 5 negative values for random variable y, and random variable y was taking y plus and y minus as two possibilities. It is 9 comma 5 split, isn't it? It is, what is the split? 9 comma 5 split means 9 positive cases, 5 negative cases. If this is 14 comma 0 split, at the what the entropy? Entropy would be 0, isn't it? Entropy would have been 0 if this is 14. If this split is 14 comma 0, entropy would have been 0 at the outset. When we started constructing decision tree, the entropy was 0.94, isn't it? Then we said, okay, if we decide to break up my data set using outlook variable, outlook has 3 possibilities. Just check outlook, how many possibilities does it have? It has sunny, overcast, rainy. Therefore it has got 3 possibilities. Given a data set D, I am breaking capital D into D1, D2 and D3, isn't it? Just see, I am breaking the data set D into 3 pieces. One is D1. D1 is related to sunny, D2 is related to overcast, and D3 is related to rainy. How many sunnies are there? This is 1, 2, isn't it? Just 3, 4, 5, isn't it? This I will split. How can I split? Just let me show that. Yes, just see, sunny, depending on sunny, 1, 2, 3, 4, 5. I am keeping in D. What's happening here? Because outlook can take 3 values, such that outlook in all the points of D1 are sunny. Just see, all the points in D1 are sunny. All the points in D2 are overcast. All the points in D3 is rainy. That's how we've broken up this data set D. We have broken up the data set D into D1, D2 and D3 based on values of outlook. What is my average entropy? 0.64. What is my weighted average entropy? 0.69. This anyway we will try to understand. Now, if you compute the entropy of class Y on D1, entropy of class label Y on data set D1, what is that? How can I calculate? I have 3 nodes. How many nodes are there? Here I have 3 nodes. No, 3 nodes, isn't it? And 2 S's. I have 2 S's. And my entropy, how can I calculate entropy? Just see, probability of playing tennis. Yes, how many S's are there? There are 2 S's. Therefore, how many S's? 2 S's. Total, how many are there? 5. Therefore, 2 by 5. Probability of playing tennis, no? 3 by 5. Why? Because no, 3 by 5. What is entropy with sunny? Minus 0.4. What is formula? Minus p into log p base 2, isn't it? Minus 0.4 into log 0.4 base 2. What is the other probability? 0.6 minus 0.6 into log 0.6 base 2. This is 0.97. You are getting 0.97. That's what it says. Entropy for this particular, the one is for D1 is, this is equal to 0.97. In similar manner, I can calculate for D2. How to calculate D2? Just see. In the case of D2, how many S's are there? All S's. Therefore, 1, 2, 3, 4 S's. Probability of playing 10 is 4, total 4, probability 1. Probability of not playing 0 by 4. Therefore, if you calculate, you will get 0 entropy, isn't it? It is completely dominating set. What about this entropy? You are saying, how will you get this entropy? Same, just like first case. Just see this one. What is probability of playing tennis? How many S's are there? There are 2 S's, therefore that is 2 by 5. How many no's? 3 by 5. That is minus 0.4 into log 0.4 base 2. Same thing, you will get 0.97, isn't it? Now what we have to do? Average entropy. How will I get average entropy? Just 0.97 plus 0 plus 0.97 by 3, that is 0.64 you will get, isn't it? What about weighted entropy? It is simple and straightforward. How can I calculate weighted entropy? Just see. Entropy among 3 branches. What is entropy among 3 branches? What is my first branch? My first branch is related to sunny, isn't it? Number of sunny days by total number of days. Well, how many sunny days are there? Here I have 5 sunny days. 1, 2, 3, 4, 5. 5. Total number of days 14. This is weighted average. This is corresponding entropy value. In similar manner, entropy number of overcast days 1, 2, 3, 4. There are 4 overcast days. Total number of days 14 into its corresponding entropy 0. Again, how many days? How many number of rainy days? How many rainy days? 1, 2, 3, 4, 5. Total 5 by total 14 into its corresponding entropy. This I can say, this is weighted entropy among 3 branches. What is this? 0.69. That's what we were saying, 0.69, isn't it? Now, what will how will I calculate? What is the reduction in randomness due to choose outlook as a decision maker? How can I calculate? Reduction in randomness is entropy source. What is source entropy? We already calculated 0.940 minus entropy of branches. Just now we calculated entropy of branches, the 3 branches, that is 0.246. The reduction in randomness called is information gain. This 0.246 is information gain. Similar calculation can be done for other features. Now we calculated outlook for outlook feature. In similar manner, we can always calculate for other features. Isn't it? Information gain is entropy at parent minus weighted average entropy of child nodes. I can write this if it is parent node. For example, let me say this is parent node. These are child nodes. Let me entropy at root node. H of y at d minus weighted average. Let me say here you have d1 points. d1 by total number of points and entropy at this point. Plus let me say here I have mod d2 points. Mod d2 by total number of points. Entropy at this point. This is third partition. Let me say mod d3. Total number of points in this partition by total number of points into corresponding entropy. This is a way to calculate. This is a way to calculate information gain, IG, isn't it? It must be information gain. Just go through this lecture. What it says, IZ, information gain means how will I write? IZ. This is information gain. H of d into y, entropy of y at root node minus sigma I equal to 1 to n mod di by mod d1. If I say I equal to 1 mod d1 by mod d into its corresponding entropy. This information gain is simple and straightforward. Just go through this lecture. If you have any difficulty, please keep a comment. Thank you very much.